So here is the circuit for this slab. So got the USB oscilloscope attached here to the breadboard. You got all these, all the components of the bridge here, all the resistors. You look over here, that R3, which is the important bit here. The Wheatstone Bridge is actually this this little guy right here. It's kind of screwy, doesn't really match up too well, but it's getting the job done. So here we have the probes. We have one channel measuring here on either side of the resistor to get an accurate reading. You'll see that right now I have it calibrated so that the potentiometer has just the right amount of resistance, so that it's canceling out this, or it's bringing down the amount of current that's flowing through R3 to effectively 0. That's why we're getting this this straight line right here, and there's no potential difference across that. So if I take, if I take a little screwdriver and I start messing with the potentiometer, start turning the screw right here, you'll see that the waveform actually starts to change. It starts to not to reverse straighten out, I guess, to start bending back. That's because the resistance is no longer at that Goldilocks value where it's negating the potential difference across that resistor. So right now we have a pretty clear signal because I've adjusted this the average, and I've also taken the liberty of adjusting the range here. If you start playing around with this, you put it on 50 millivolts, you start getting a more noisy signal. Let's try to see if I can clean that up a bit, maybe just a little bit, and see it's not as noisy because it has it's taking the average of all these positions. But if I were to reduce that to one sample, like by moving this one from 20 where it was to 1, see that the signal starts getting noisy again, and you have all this fuzz. But if I take the average over here, it more or less straightens out, and then by adjusting the range over here back to what I had it, we can get more of a straight, a clear signal. So there's that. You have your peak to peak value over here. If you want to, you can see here. You can see the units for this peak to peak. And I guess the other reason why I do want to find the minimal value is because again, once the potential difference across that section of the bridge, across this right here, across this resistor, is this resistor right here. Once that is at its minimum or 0, the voltage difference will be 0, and so you'll be able to find out the resistance of, or you'll be able to calculate the unknown impedance in your circuit.